This is the key to quiz number 6 on rational expressions. So problem number one, you want to simplify the following rational expressions. And then notice it says you must show what factors are being reduced. So in this problem, we have 25 minus x squared divided by x squared minus 8x plus 15. So the first thing you need to do is to factor the numerator and then factor the denominator. In the numerator, you'll notice that 25 minus x squared is the difference of two squares. And so I can factor that as 5 minus x times 5 plus x. The denominator I can factor as the product of two factors. So I get, this is going to be x minus 5 times x minus 3. And so the first thing you have to do is to factor the numerator and the denominator, and that's what you see here. What you have to notice, though, is that the next step, you have to reduce any common factors. Now, you'll notice that the first factor up here in the numerator is 5 minus x. You don't see exactly 5 minus x in the denominator, an exact factor. The same thing for 5 plus x, but I want you to notice is that 5 minus x and x minus 5 are opposites. So remember, when you divide opposites, that quotient is a -1. So -1. So for example, I'm just kind of remind you. So remember, -8 divided by 8. So -8 and 8 are opposites, and when you divide that, you get a -1. So basically, you're saying this: 8 divided by 8 is 1, and then 8 divided by -8 is a -1, and then -1 divided by 1 is a -1. So that's what you see here. So whenever you divide opposites, that quotient is a -1. So when you reduce those factors, you end up with -1, and that's what you have here. So these are factors. 5 minus x. So if you look at it, the opposite of 5 is a -5, and the opposite of a -x is a positive x. So those are opposites. So therefore, when I do this, and that's what I mean by show what factors are being reduced. So x minus 5 divided by x is 1, and then when I divide 5 minus x by x minus 5, I get a -1. And so there are several ways you can write your answer. So some of you may have said this. You may have said -1 times 5 plus x divided by x minus 3, and that's fine. Some of you distributed the -1. So you said -5 minus x, all divided by x minus 3, and that's fine as well. The more preferable way, though, and that's what I'm going to put in the blank, is to put that -1 out in front of that fraction. So you basically have this, negative, and then the numerator is 5 plus x, and the denominator is x minus 3. So that is basically what you're going to see most of the time, almost all the time, when you're working these out. All right, but either one of those is fine, but this is the more preferable way to write the answer. All right, number 2, same thing. You want to simplify the rational expression, except this time we have two trinomials, two quadratic trinomials. So let's go ahead and factor the numerator. So when I factor the numerator, I'm going to get, let's see, that's going to be x plus 6 times x plus 2. And the denominator, when I factor x squared minus 2x minus 8, I'm going to get x minus 4 times x plus 2. All right, so the first thing you have to do was to factor. The next thing you have to do is to reduce any common factors, and I need for you to show that. So when I say show that, I want you to notice that in the numerator, the denominator, the only factors that you see they have exactly in common is x plus 2. So when you divide those out, you get factors of 1s in their place. Makes sense because x plus 2 divided by x plus 2 is 1, right? And so therefore you get x plus 6 times 1 is x plus 6, and then x minus 4 times 1 is x minus 4. And there's the answer that goes into this blank. All right, so that's problem number 2. All right, problem number 3, we have, now this one's a multiple choice. And so the direction said find the least common denominator of the two rational expressions that you see here. So the first thing you want to do when finding the least common denominator is to factor those denominators. So if I look at that first denominator, x squared plus 8x plus 16, and I factor that, I'm going to get x plus 4 times x plus 4, right? So there are two factors of x plus 4, and you can also write it as x plus 4 squared. In the second one, where I have x squared plus 4x, and I factor that, notice the GCF, the greatest common factor of those two terms is x. I can factor out an x, and I'm left with x times x plus 4. So there are two factors of x plus 4 here. There's one factor of x here and one factor of x plus 4 here. So remember, the least common denominator, when you look at your least common denominator, you must include every factor that's in those denominators. So I see a factor of x, so I have to use it. I'm going to put that first since that's my monomial. I see a factor of x plus 4 in this one. I also see two of them here. So there's one here, x plus 4, and there are two factors of x plus 4 here. You always have to use the one with the largest exponent. So you have to use the one that has the most factors. So I have to use x plus 4 to the second power. So there's your least common denominator. So that's going to be choice B right here. All right, number 4. So in number 4, this time you want to subtract those two rational expressions. So when subtracting rational expressions, you have to first of all find the least common denominator. So we're going to have to end up rewriting those two rational expressions you see into equivalent expressions that have the same denominator. So when adding or subtracting rational expressions, we have to find the least common denominator. And remember, before we find the least common denominator, just like we did in the previous problem, you're going to have to factor the denominators. So let's go ahead and do that. So you'll notice 2x minus 3, it's a linear factor. The GCF is 1, so you cannot factor that. Same thing for x minus 5. I cannot factor x minus 5. So therefore, the least common denominator will be a product of each of those factors, 2x minus 3 times x minus 5. All right, now here's the work. So I'm going to go ahead and rewrite this over. X plus 1 divided by 2x minus 3. And I'm going to leave some space here, and I'm going to subtract 3x plus 2 divided by x minus 5. Okay, now, when writing equivalent fractions, so you want to rewrite this fraction into a fraction that has this denominator, 2x minus 3 times x minus 5. Subtract, and then the same thing here. 2x minus 3 times x minus 5. All right, so remember what you need to do. So if you look at that first fraction, that first rational expression, I have a 2x minus 3, but I need to multiply by x minus 5, right? So what that means is that if I'm going to multiply that denominator by x minus 5, I've got to do the same thing to the numerator. Same thing here. Here's an x minus 5. I'm missing the 2x minus 3, so I got to multiply the denominator by 2x minus 3. But if notice I'm putting parentheses here, but if I multiply the denominator by 2x minus 3, I also have to multiply the numerator by 2x minus 3 as well. Notice that work. What you do to the numerator, you have to do to the denominator, and so you have to show that. See, x minus 5, x minus 5. 2x minus 3, 2x minus 3. All right, now what you're going to do next is, now always leave the denominators in factored form, but notice in the numerator, you want to multiply those two binomials out. And so we can use the fall method. X times x is x squared. The outer, x times a negative 5 is a negative 5x. The inner, 1 times x is a positive x. And the last, 1 times a negative 5 is a negative 5. In the second numerator, same thing, fall method. 3x times 2x is 6x squared. The outer, 3x times a negative 3 is a negative 9x. The inner, 2 times 2x is 4x. And then the last, 2 times a negative 3 is a negative 6. Okay, now, let's go ahead and combine like terms in both numerator and denominator before we go any further into writing this as one fraction. So basically, we have this. We have x squared. Negative 5x and x is a negative 4x minus 5 divided by 2x minus 3 times x minus 5. Always leave the denominator in factored form. Subtract, and then over here, I get 6x squared. A negative 9x plus 4x is a negative 5x, and then minus 6. All divided by 2x minus 3 times x minus 5. Okay, now, let's go ahead, since I rewrote, and this right here, so since I rewrote the original problem into two equivalent rational expressions that have the same denominator, I can write this as one fraction. So I get x squared minus 4x minus 5, subtract, and be careful, this is subtraction. So what that means is this. Since I'm subtracting all of this numerator. So I need to put that in parentheses. That's important because you're subtracting each of those terms. All of that is being divided by that common denominator, which is 2x minus 3 times x minus 5. And now getting rid of the parentheses by distributing at -1, or thinking about this as, remember, subtraction means the same thing as adding the opposite of each of those terms. So I get x squared minus 4x, that's a 4x, so let's do this over. X squared minus 4x minus 5, and then the opposite of 6x squared is a negative 6x squared. The opposite of a negative 5x is a positive 5x, and the opposite of a negative 6 is a positive 6. All of that is being divided by 2x minus 3 times x minus 5. And now combining like terms in the numerator, I get negative 5x squared, because x squared and negative 6x squared is a negative 5x squared. A negative 4x and a positive 5x is a positive x. A negative 5 and a positive 6 is a positive 1, all divided by 2x minus 3 times x minus 5. And there's this numerator, you cannot factor that, so leave that as it is. All right, so you get that. Now what some students did was, you see where you have that x squared is a negative coefficient? Some students, they factor out a -1, but that was not necessary. So meaning they wrote it as, when they factor out the -1, they wrote it like this. So remember that they're taking out a -1 from that numerator. So basically you're just changing all these signs. So it would be 5x squared minus x minus 1 divided by 2x minus 3 times x minus 5. Now that's what I saw. But most students will leave it like this. They won't factor out a -1 from that numerator. Okay? All right, but there's the work. So quite a bit of work here for this problem. All right, let's look at number 5. So number 5, this time you're adding these two rational expressions. And this one's a little bit easier than problem number 4. But again, you want to find the least common denominator first, because when adding or subtracting fractions, you want to make sure that those denominators are the same. So here's the work you had to do. So first of all, remember you have to factor the denominators first, right? And so when I do that, let me just kind of show you this. So when I do that, you're going to get 2 divided by 6 times x plus 5. So I can factor out a 6 from that denominator, plus 2x minus 3 divided by x plus 5, right? And now let's go ahead and find the least common denominator. And so if you leave it as this, the least common denominator I would expect you to say would be 6 times x plus 5, right? Now here's what some of you did. Some of you noticed, hey, I can reduce a 2 and a 6, and you have to show this. So if you leave it like this, then this is what I would expect you to say. If you wrote it like this, where you said 2 divided by 2 is 1, 2 divided by 6 is 3, then you would say this. Then you would say r, well, in this case, you would say 3 times x plus 5. So either one of those is fine, but I needed to see either this or this, okay? All right, now I'm going to go ahead and use this one because that's what most of you did. And so I'm going to leave it as 6 times x plus 5 as the least common denominator. So now we're going to write two equivalent fractions using this as my least common denominator. So I'm going to go ahead and rewrite this over. So I get 2 divided by 6 times x plus 5. I'm going to leave some space, plus 2x minus 3 divided by x plus 5. All right, now notice, this is what I have. This is what I want. Notice those are the same. So this fraction is equivalent to itself. It already has that least common denominator. Over here, though, I have x plus 6. I'm sorry, x plus 5, but I'm missing that 6, right? So that means that this fraction here is going to be equivalent to this one. So I need a 6 down here. So I'm going to multiply this by 6. But what I do to the denominator, I must do to the numerator. Notice I'm putting this in parentheses because that's going to be important in a little while. Now when you do this one, just to show you, then this is what you would say. You would say 3 times x plus 5 plus, and then I'm just rewriting this over. That's a 1 here. And then x plus 5, 2x minus 3. Okay, so notice if you use this one, the least common denominator you say was going to be 3 times x plus 5. So notice the original expression is equivalent to itself, so that's going to stay the same. Over here, though, I have the x plus 5, I'm missing the 3. So I'm going to multiply, in this case, I'm going to do it here. So in this case, I multiply the denominator by 3 and the numerator by 3. So notice the difference between these two. Okay, now let's go ahead and get rid of the parentheses in the numerator. Now remember, when adding, subtracting fractions, you want to make sure that those denominators are the same, so at some point you can write it as one fraction. So I get 2 divided by 6 times x plus 5 plus, and then I'm going to go ahead and distribute this right here. So distribute the 6. So 2x times 6 is 12x, and then negative 3 times 6 is a negative 18, all divided by 6 times x plus 5. So if I did this one, you would have said this. You would have said 1 divided by 3 times x plus 5 plus, and then distributed 3. 2x times 3 is 6x. And negative 3 times 3 is a negative 9, all divided by 3 times x plus 5. All right, and now we're going to write this as one fraction. So my denominator is going to be 6 times x plus 5. My numerator is 2 plus 12x minus 18. Over here, that's going to be 3 times x plus 5. And my numerator will be 1 plus 6x minus 9. Combining like terms over here in the numerator, I get 12x, 2 and a negative 18 is a negative 16 divided by 6 times x plus 5. Over here, I get 6x, and then 1 and a negative 9 is a negative 8 divided by 3 times x plus 5. Okay, now remember, always reduce as much as possible. So what I want you to notice is that over here in the numerator, I can factor out a 4, and that's going to be necessary because of this. So when I factor out a 4, I get 4 times 3x minus 4 divided by 6 times x plus 5. The reason that factoring out a 4 was necessary here is because I could reduce further. So always reduce as much as possible. So when I reduce the 4 and the 6, this is going to become 2 and 3, right? So it's going to be 2 times 3x minus 4 divided by 3 times x plus 5. Over here, notice that the numerator, I can factor out a 2, but that's not necessary because it's not reducible. So, but most students did do that. So you would say 2 times 3x minus 4 divided by 3 times x plus 5. And notice those two are the same. You cannot reduce any further. All right. But for this one, if you use this one, you must reduce as much as possible. So it's important that you had to factor out a 4 to see that that 4 and that 6 can be reduced. And so that would have been the answer you would have given me. Some students went ahead and distributed the 3 and the 2, and that's fine. So they said 2 times 3x is 6x, 2 times a negative 4 is a negative 8, divided by 3 times x is 3x, and then 3 times 5 is 15. So that's fine as well. All right, so either one of those would have been a correct answer. So that was problem number 5. Okay, problem number 6. You want to multiply these two rational expressions. So let me go ahead and rewrite this over. So in that first rational expression, you have x squared plus 8x plus 12 divided by x squared plus 10x plus 24 times, and then that's x squared plus 4x divided by x squared minus x minus 6. All right, so when multiplying or dividing rational expressions, you want to first of all make sure that you factor each of those numerators and denominators. So in that first numerator, I can factor that as x plus 6 times x plus 2. The denominator, I can factor as x plus 6 times x plus 4 times. The numerator here, I can factor this by first factoring out an x. That's the GCF is x. So I get x times x plus 4 divided by, and then in the denominator, I get x minus 3 times x plus 2. So that's what I had to see first. I had to see this right here, right here. So all of these factors times all of these factors. Now, remember, you want to show how the factors are reduced. So the x plus 6 is divided out. I see an x plus 2 here. I see 1 in the denominator, so that divides out just like this. There's a factor of x. I don't see a factor of x anywhere, but I do see a factor of x plus 4. So those divide out, and that's it. So therefore, my answer is going to be 1 times x times 1, which is x, divided by, and then 1 times 1 times 1 times x minus 3 is x minus 3. And so there's the answer there. So x divided by x minus 3. So that's problem number 6. Problem number 7. This time you're dividing, so let me go ahead and rewrite this over. So you get x squared minus 25 divided by x squared plus 4x minus 12 divided by x squared plus x minus 20 divided by x plus 6. So the first thing you need to do is to change this division to multiplication. So we're going to change it to multiplication problem. And so in changing this to multiplication problem, you're going to have to multiply by the reciprocal of the fraction following the division symbol. So the next step you would have to say x plus 6 divided by x squared plus x minus 20. And that first fraction stays as it is, so x squared minus 25 divided by x squared plus 4x minus 12. And now the next step is to do in the previous problem, you're going to factor all the numerators and factor all the denominators. So in that first numerator, this is the difference of two squares. So I can factor this as x minus 5 times x plus 5. The denominator, I can factor that as x plus 6, x minus 2 times, and then this stays x plus 6. The denominator I can factor as x plus 5, x minus 4. So that was the next step. So you have to show this, and then the next step is to show how those factors are being reduced. So I have an x minus 5, I don't see 1 down here. I have an x plus 5, I see 1 right here. So those divide out. I see an x plus 6 up here and down here as well in the denominator, and that's it. So my numerator is going to be x minus 5 times 1, which is x minus 5, divided by, and this is 1 times x minus 2 times 1 times x minus 4, which is just x minus 2 times x minus 4. And there's your answer. Some of you multiplied the denominators, the two binomials out that's in the denominator, but that's the more preferable one. But some of you did this. You said x minus 5 divided by, and when you FOIL this out, you got x squared minus 6x plus 8. So either one of those is fine. All right, so that is number 7. All right, now number 8, you wanted to solve this rational equation. And so again, the first thing you have to do is to find the least common denominator. And if you notice, this x plus 4 cannot be reduced any further. This x minus 6, I meant factor any further. X minus 6 cannot be factored, but this one can, this trinomial that's in this denominator. And when I factor that, I'm going to get x minus 6 times x plus 4. And so remember, to find the least common denominator, your least common denominator will include every factor that you see. So I see an x plus 4, I see an x minus 6, I see an x minus 6, I already talked about. So far I have x plus 4 times x minus 6. And I see an x plus 4 and I already have it. All right, so my least common denominator is just x plus 4 times x minus 6. Now the way to do this is this way. So you have to say this. So here's my original equation. So I'm going to go ahead and multiply both sides of that equation by that least common denominator. And so this is what you should put next. You're supposed to put x plus 4 times x minus 6 times, and then you're going to multiply this by the left-hand side. So 7 divided by x plus 4 minus 2 divided by x minus 6 equal, and then this right-hand side times the least common denominator. So x plus 4 times x minus 6 times the right-hand side, which is 3x minus 5, divided by, and we're going to rewrite the x squared minus 2x minus 24 into those factored parts. So the x minus 6 times x plus 4. All right, now over here, the next step is to get rid of these brackets that I've introduced. So I'm going to go ahead and distribute now. And so I'm going to get x plus 4 times x minus 6 times that first fraction, 7 divided by x plus 4, minus, and then the LCD, x plus 4 times x minus 6 times that second fraction, 2 divided by x minus 6, equal. Now remember, the whole purpose of multiplying both sides of that equation by the LCD, now that's an equation, so that's where you multiply, that's why you're multiplying both sides by the least common denominator, is to get those denominators to be factors of 1. And so if you notice right here, these divide out, and then these divide out, right? And so notice that denominator, 1 times 1 is 1. And so you have 1 times 3x minus 5 divided by 1, which is just 3x minus 5. Over here, I'm going to go ahead and reduce the x plus 4s now, and then we reduce the x minus 6s. And so now what we have is 1 times x minus 6 times 7, which I can rewrite as 7 times x minus 6, minus subtract 2 times x plus 4, make sure you put the x plus 4 in parentheses, equal 3x minus 5. So notice I went from a rational equation to a linear equation. So now all I have to do is just solve this linear equation. So I'm going to go ahead and distribute in both cases here. So I get 7x minus 42. A negative 2 times x is a negative 2x, and a negative 2 times 4 is a negative 8, equal 3x minus 5. Combining like terms, 7x and a negative 2x is 5x. A negative 42 and a negative 8 is a negative 50, equal 3x minus 5. And then let's go ahead and bring all the variables to one side. So I'm going to subtract 3x on both sides. So 5x minus 3x is 2x minus 50 equal, and then we're left with negative 5. Adding 50 to both sides, I get 2x equal, this is 0, remember. Negative 5 and 50 is 45. And then dividing both sides by 2, I get x to be 45 halves. And so there's the solution. So 45 halves would go into this blank. All right, now number 9, we have this rational equation. And notice, again, you want to solve this rational equation, you want to multiply both sides of this rational equation by the LCD. So the LCD is going to include every factor that you see. Just make sure that the denominators are factored, which you cannot factor any further. So x and x minus 15, that's it. It's just x and x minus 15. That's your least common denominator. Just as the previous problem, we're going to multiply both sides of that equation by that least common denominator. So I get x times x minus 15 times the left-hand side, which is 3 divided by x plus 15 divided by x minus 15, equal, and then x times x minus 15 times 3x minus 6 divided by x minus 15. Okay, and then distributing over here, we get x, the LCD, which is x times x minus 15 times that first fraction, plus, and then the LCD, which is x times x minus 15 times that second fraction, equal, and then I'm going to go ahead and reduce what I have here. So the x minus 15 can be reduced, but look at what you have though. You have x times 1, which is x, times 3x minus 6. So this is what you have. You have x times 3x minus 6. Notice it was important that you put 3x minus 6 in parentheses, because all of these terms have to be multiplied by x. So that was important. Reducing here, the x's divide out, and so notice I have 3 times x minus 15, notice in parentheses, right? And then the x minus 15's divide out, and you just get plus x times 1 times 15 is 15x, equal, and I'm just going to go ahead and rewrite it like this, 3x minus 6. All right, now let's go ahead and distribute, get rid of the parentheses here, and then do the same thing here. I get 3 times x is 3x, 3 times negative 15 is a negative 45, plus 15x, equal, x times 3x is 3x squared, x times a negative 6 is a negative 6x. I want you to notice that in the previous problem, in problem number 8, you ended up with a linear equation. In problem number 9, you ended up with a quadratic equation. So keep that in mind. So this time we're solving a quadratic equation. So I went from a rational equation to a quadratic equation. And remember, when solving a rational equation, you really, and we didn't do this in the other problem, we should have, you really needed to find the restrictions. Because when I found that the solution was 45 over 2, I had to make sure that that was not a restriction. So remember, your restriction is any value of x that makes the denominator 0. So notice that for x plus 4, negative 4 makes my denominator 0. And over here, positive 6 makes my denominator 0. Same thing here, positive 6, negative 4. So those are restrictions. So basically, x cannot equal those two numbers. So when I solved this, if you recall, when I solved this, you had to first of all check to make sure it was not a restriction. And it wasn't. So that's why we automatically said that 45 over 2 would be a solution, because 45 divided by 2 does not make my denominator 0. Because remember, when you divide by 0, that is undefined. So when I do this one, I should first of all determine what the restrictions are. So if you look at your first factor, my first factor is x. So what makes a denominator 0? Well, when x is 0, right? The other one, x minus 15, what makes that 0 is when x is 15. And then over the same thing here, what makes that 0 is when x is 15. So my restrictions is that x cannot equal 0, 15. So when I solve this quadratic equation and I get any of those restrictions, I cannot use that. That would not be a solution. All right, so just keep that in mind. All right, so let's continue on solving this quadratic equation. So when I combine like terms, 3x and 15x is 18x minus 45 equal 3x squared minus 6x. All right, so to solve this quadratic equation, we need to put this in standard form. So I'm going to bring all these terms to the other side. So meaning I'm going to subtract 18x from both sides, and I'm going to add 45 to both sides, right? So what I do to one side, I do to the other. Now when I combine like terms, 18x is 0, 18x and negative 18x is 0, a negative 45 and 45 is 0, and 0 plus 0 is 0. So 0 is needed here, equal 3x squared. Negative 6x and a negative 18x is a negative 26x, right? Plus 45. I'm sorry, yes. All right, so that should be 24, right? 24x, sorry. Okay, now I'm going to go ahead and put this, see I have left-hand side equals the right-hand side, so I'm going to just transpose the sides. So I get 3x squared minus 24x plus 45 equals 0. Okay, so I need to factor this. So I can use quadratic formula, or I could, and this one's factorable, so you can factor this. But what I want you to notice is make it easy on yourself. Notice that each of those terms, they have a 3 in common. See that 3? And then negative 24 is divisible by 3, and 45 is divisible by 3. So that means I can factor out a 3. And so that's going to make things a lot easier for me. So when I factor out a 3, I get 3 times x squared minus 8x plus 15 equals 0. And notice I'm going to cover up the 3. I can easily factor this now. So when I factor this, I'm going to get x minus 5 times x minus 3 equals 0. Don't forget to put the 3 back. All right, and then all you got to do now is find out what values of x. You have this product here is 0. So you got to find out what values of x makes one of those factors 0. So 3 does not have a variable x in it. So if this product is 0, then it has to come from either this one or this one, right? So I get x minus 5 equals 0, x minus 3 equals 0. And notice I'm solving these two linear equations. So I get x to be 5, x to be 3. And notice 5 and 3 are both not a restriction. So therefore, those are both your solutions. So my solutions are 5 and 3. Okay? All right, so that was the key to this quiz on rational expressions.